All right, hello everybody. Working on our linear functions. I'm going to go through this review. Please let me know if anything's confusing. Happy to slow down and go over more like that. So, first problem that we're talking about here is the algebra party. So, math teachers are buying cups for $5 each. We're going to call that X. Rope for $3 each. We're going to call that Y. We spend a total of $30. So this is one of those situations that I like to call a combination of two things to make a total. Two things combined to make a total. That would be a standard form situation where we have, I'll start with the X instead. We have $5 per X, $5 for cups, $3 for ropes, spending $30 total dollars. So $5 times however many cups you buy, plus $3 times however much rope you buy, $30 total. And it asks us to graph this equation. So let me rewrite it where we can see it. So we said 5x plus 3y equals 30. One way that we can do this is by getting the x and y intercepts. A different way to do it is by converting it to y equals mx plus b. I'll show the x and y intercepts here. I'm sure later we'll convert. So if I want to find the x-intercept, I'm just going to completely ignore y. In other words, I'm making the y value equal 0, but I'm just going to ignore it. If I have 5 times x equals 30, I know that 5 times 6 is 30. In other words, 30 divided by 5 is 6. That tells me an x-intercept, so I'm going down here to the bottom of the graph, 1, 2, 3, 4, 5, 6. I'm putting a dot right there. That dot down there represents that I bought 6 cups, 0 rope. Similarly, I could solve the other equation where I ignore x and I just solve for y. 3y equals 30, divide by 3 on both sides, I get y equals 10. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. And now what I want you to notice is I can connect those two dots. I know it's linear, so I can connect those two dots like this. It's a little bit hard to do on my computer screen, but you can see that it actually passes perfectly through this point right here. And this point right here is a little bit of a harder point to find just off the top of your head. It was not too hard to come up that 0, 10. If you make x 0 and y 10, you spend all 30 of your dollars. And similarly, it wasn't too hard to come up with 6, 0, but it's a little bit trickier to come up with that combination in the middle of 3 and 5. 3 and 5 works just as well, because that would mean 3 cups and 5 ropes. 3 cups would cost 15, 5 ropes would also cost 15, that would be $30 total. Those are the 3 solutions to the equation, and I've explained what each of them means already. All 10 meters of rope, 3 cups and 5 meters of rope, or 6 cups and 0 meters of rope. Great, moving along. Oh, come on. There we go. All right. Now we're asked to write equation in standard form. Very similar situation as before. 3 apples and 4 juices for $12. Now, I typed this here in all caps. Define your variables. That must mean it's important. I wrote it in all caps. Did I define my variables? No. I didn't tell you what x and y stood for. So I need to tell you what x and y stand for. X and y are the things that you don't know about the problem. They're the things that can vary or change. In this problem, don't write x as apples. We know that there's 3 apples. The number of apples doesn't change. Don't tell me that x stands for apples. X stands for the price of apples, or you could use the word cost. Price of apples. And similarly, I almost put 2 s's at the end there. Y stands for the price of juices. Again, y is not the number of juices, it's the price of juices. That's the thing that can change. Now in 2b, it asks me to convert that equation to slope-intercept form. So the first thing I'm going to do is get my x's away. I'm going to subtract 3x. So now I have 4y equals negative 3x plus 12. You'll notice that I didn't write down 9. I just moved the x's to the other side. What I'm really doing is I'm subtracting the same thing from both sides. I'm subtracting 3x from the left side. 3x minus 3x is 0, so I don't need to write them on the left side anymore. And I'm subtracting 3x from the right side, and there's now 0 minus 3x. That's why I wrote a negative 3 on the right side. Then I divide by 4. Please don't grab your calculator to do some fraction. You actually just want to leave it as negative 3/4. 12 divided by 4 comes out to be the whole number 3. If I graph that, 3 is my y-intercept, so I can put a dot right here at y equals 3. And then negative 3/4 is my rise over run. I can go down 3 because it's a negative on the numerator, over 4 because 4 is the denominator. That's my rise over run. And you can see that this one looks very similar to the last one. It makes sense that these have a negative slope because the more that one thing costs, the less that the other one can cost if you're going to spend $12 total. Okay, question 3 is virtually identical, so let's just go through it just a tiny bit quicker. 275x, because those are the cost of tacos. 550y, those are the cost of burritos, equals 1925. I'll just mention that here I know the cost, so I don't know the number. X is the number of tacos in the way I wrote the equation. Y is the number of burritos. Convert it to slope-intercept form, practically the same thing. Move the x's over. 550y equals negative 275x plus 1925, and then divide everything by 550. Let's see, what is 1925 divided by 550? Does that come out to be a nice one? 1925, oops, helps if you type it in right. 3.5. So I get y equals negative 1/2 x plus 3.5. So this can be a little tricky to graph. I'm going to try to graph it. I'll graph it to a different color. So 3.5, I've got to count up 1, 2, 3.5 dots. So imagine that bluish dot is exactly halfway between the 3 and the 4. And then I'm going to go down 1 and over 2. So another one that's halfway in between. Another nice trick is that I could have gone down half a box and over 1. And you can see how that lines up perfectly in between. So this is like going like that. It should hit right here at 7. Okay. And I can even extend it past if I want to. Okay, let's keep on scooting down. Now we're just asked to calculate the slope. Slope is just rise over run. So just think about how much are the y values. Oops, I gotta switch to my pen. Think about how much the y values are going and how much the x values are going. Oh dear. There we go. Okay, so how much are the y values going up? From negative 5 up to negative 11, that's actually going down 6. That's the rise. How much are the x's changing? From 4 to 4, that's actually a run of 0. I can't divide by 0. The slope here is undefined, or you could say it doesn't exist. You can say can't divide by 0. You can just draw a frowny face. I need to see in your work that you had a 0 on the denominator. If you wanted to show your work a little bit more clearly, you could say that you were doing negative 11 minus negative 5 over 4 minus 4. I'm also okay with you doing it in your head like that. On part B, we're doing basically the same thing. 10 minus 10 is a rise of 0. 13 minus 8 is a run of 5, excuse me. In other words, the y values went up 0. They didn't change. The x values went up 5. This one I can calculate. 0 divided by 5 is 0. Slope of this line here, I've just got to find some good points where it crosses. This looks like it crosses exactly through a point there. And maybe this one here. So it looks to me like we're going up by 3 and over 2. That's my rise over run, 3 over 2. All right, scooting on down. Amelia has $15 in her wallet, spends $3 every lunch. X is the meals, Y is the money. So that makes me think she starts with 15 and loses $3 over and over again. Or you could write it like this, negative 3x plus 15. Both of those are fine. The second one is written in mx plus b form, which a lot of you are more used to, where m is the change and b is the start. She starts out with $15. Every one step she takes to the right, she goes down another 3. And you can see that those points line up very nicely. You can use the graph to answer these questions, but I asked you to solve them algebraically. But if you used the graph, you could see the answer for after 4 lunches is 3. And when will she have $6 left is also 3. But those 3's mean different things. The first one means $3 left, and the second one means 3 lunches. Now, how would you do that algebraically? 4 lunches is an x value. So I write y equals 15 minus 3, plug in 4 for x. 3 times 4 is 12. 15 minus 12 is 3. That's my answer. When will she have $6 left? $6 is a y value. So my equation now, I replace the letter y with 6, and then I solve for x. Take away 15 from both sides. In other words, she spent $9. That's why it says negative 9 is negative 3x, because she spent $9. Let's divide that by 3. We get 3 equals x, meaning she has purchased 3 lunches. All right, scooting on down. Now we have a table, and we're assuming it's linear, meaning it goes up by the same amount every time. So if it goes up by 6 here, half of that is 3. If I continue that pattern, I'm going up by 3 each time, so I get 9 right here. If it's a linear pattern, you can look at them as just 2 separate linear patterns. What is the run for x, and what is the rise for y? Halfway between 4 and 8 is 6. Then I can see it's a going up 2 pattern, like that. My slope is 2 over 3, because its y value is rising by 2 and its x value is running by 3. So I can write an equation of mx plus b, and I knew that the b was 4 because that's what y is when x is 0. I can graph my equation here, and I can go up 1, 2 over 1, 2, 3, up 2 over 3, connect the dots like this. Solve algebraically. What will x be when y is equal to 60? Replace y with 60 and go from there. First we minus 4 from both sides. So 56 is 2/3 x. Then you divide both sides by 2/3. If you just grab that with parentheses on your calculator, it should work out just fine. 56 divided by 2/3 is the same as, let's see, 84. There we go. All right, just a few more. This is a pattern where it's adding another stack each time. So you can see that figure 4 is going to look like this. And they're going to have 4 units here. Oops, I shouldn't have added that on. I was trying to make it clearer and I made it less clear. Okay, so it should be 4 steps tall. Maybe if I use a different color, we can make that clearer. what I'm saying is that like this size is 4 steps tall. If I was going to change it into figure 5, I would just add another row on the bottom and make it 5 steps tall. So let's define our variables. X is the figure number, and y is the number of squares, or blocks, or tiles. So when I look at this equation right here, I notice that it's 4 times the figure number. Each time I go up 1 figure number, I add 4 blocks. And then there's those 2 extra blocks at the top. So 4x plus 2. And I can go through and graph it like this. I'm going to go ahead and not graph the negatives because it doesn't really make sense to talk about negative figures or negative blocks. So I'll just graph the positive chunk. Okay, we're almost done. Just some graphs. On all of these, I'm just doing, well, not on all of them. I'll slow down a little bit. This is my B. This is my M. B is -5, so I start there. M is 4/3, so I go up 4 and over 3. Then I go another up 4 over another 3. And I got a line. On B, this is B, this is M. So I start up here at 6. Then I go down 3 over 1. Then I go down 3 over 1 again. So I've got a negative slope. On part C, you might notice it's different. It just says y equals 5. Okay, so I'll start at y equals 5. And then I'll do another point where y equals 5. And then I'll do another point over here where y is equal to 5. And I'll do another point over here where y is equal to 5. And over here, y is equal to 5. You might notice that I'm just putting dots wherever I see y is equal to 5. In other words, it's a horizontal line. Look at part D. Part D says y equals x. Well, I know that if I go to this point, the y value is 0 and so is the x value. I know that right here, the y value is 5 and so is the x value. I know right here, both the y equal the x equals 10. Every point along this 45-degree angled line has a y value that's equal to the x value. What if y had to equal -x? Well, y could be 0 and x could be 0, because 0 is the same as -0. I could go here at x is 5 and y is -5. X is 10 and y is -10. In fact, this other line, diagonally, like that direction, every y value is negative of the x value. Last one, x is -8. Here's a point where x is -8. Here's another point where x is -8. Here's another point where x is -8. Here's another point where x is -8. You'll notice that every point that has an x value of -8 is a vertical line. So, thanks for watching. Again, I went through some of that quickly. Please let me know if there's anything tricky. Happy to help.